This set of explanations is going to be our naming other organic compounds. So we're going to expand on our organic functional groups from table R, and we're going to be recognizing them, and we're going to be giving them a name. So again, we need to use reference table R, which I did not erase from our last time. So I'm just going to do a little bit of erasing here if I can. All right, so on our reference table R, we have to be able to, I don't know why this doesn't want to move. We have to be able to evaluate things, and we need to be able to give them a name. And of course, I'm having some computer issues. Okay, I'm going to switch to my tablet mode, and we're going to get started. All right, so you should have table R, and you should have table R open. And I will be flipping back and forth, and hopefully the pen and all of that stuff feels like it's going to work for me today. All right, so the first thing I'm going to do before I name them is I need to be able to identify what class of organic compound this is going to be from. So I need to find the functional group. The functional group is whatever just looks weird in a chain of carbons and hydrogens. So in this case, here is the functional group, and I have an OH at the end. So when I go to my reference tables and I've got this OH like sticking off like a branch, and I take a look and I see what I've got, it looks to me like I have an alcohol. So if you think that that's an alcohol, that's, you're going to be absolutely correct that that's going to be an alcohol. And I don't think I can erase. I keep trying, but yet it doesn't want to happen for me. And we'll do that. That lets me move. That's supposed to let me freeze. And that's supposed to let me erase. But no. Okay, well, we're going to forget the erasing. Okay. And I'm also breaking my stylus, so I may have to just go with a different option. Okay. Organic worksheets. Okay. And so I know that this is an alcohol. So alcohol. And I'm going to name this just like the alcohol on table R. So my alcohol on table R says that this is 2-chloropropane. Well, prop means 3 carbons according to table P, right? So I've got 3 carbon. Oh, sorry, I'm looking at the wrong one. Propanol, sorry. And it's 1 propanol. Prop because it has 3 carbons. 1, 2, 3. OL to indicate that it's an alcohol. And the number 1 indicates where is the OH located. It's located at the end of the molecule. So now let's name ours. I have 2 carbons. So I'm going to take the prefix F, and since it's connected with single bonds, ANE, but I'm going to drop the E and I'm going to add the ending OL. So then that means it's an alcohol. And now I don't have to say where that OH is located because no matter where I put it, it's the same. If I put it here, it's the same as here. And if I put it here, it's the same thing if I just flipped this thing over. So this is just ethanol. Now let's go on to our next one. So in this question number 2, I have a carbon-oxygen double bond, and it's right there in the middle of the molecule. So I'm going to take a look, and I'm going to see which one does this match most like on my table R. Oxygen with a double bond, smack dab in the middle to the oxygen. So oxygen with a double bond, smack dab in the middle, is going to be a ketone. And again, it doesn't want to let me erase, and it's frustrating me. And okay, so I'm going to name this just like this ketone. This ketone is called pentanone because it has 5 carbons. 1, 2, 3, 4, 5. ONE singles out the ending, right? That makes this a ketone. And the number 2 means that the ketone functional group is on carbon number 2. So now on my worksheet, I need to count the carbons 1, 2, 3. The prefix for 3 is prop. So this is kind of like propane, but I'm dropping the E and I'm adding the ending "one." So this is propanone. This is I don't need a number because this is the only location it could be, because the functional group has to be in the middle, not on the end. If it was on the end, it wouldn't be a ketone anymore. It would be an aldehyde. So then that's just propanone. Now I'm going to take my look at my next one. This is my functional group because it's what looks different. And I'm going to figure out which one does it look like on table R. I have a carbon-oxygen double bond. Carbon-oxygen double bond to the oxygen, and then the hydrogen at the end. So the carbon-oxygen double bond with the hydrogen at the end looks like this. So I'm going to call this an aldehyde. And then this one is called propanal for the aldehyde. So it looks like I'm changing the ending to Al. And prop means however many carbons there are, because then that's got 3. So now let's look at ours. So ours has 1, 2, 3, 4 carbons. So the prefix for 4 is but. So I'm going to name it like a hydrocarbon, like butane. I'm dropping the E, and I'm changing the ending to Al because this is an aldehyde. And I don't need a number because the aldehyde functional group is always at the end of the molecule. Now let's look at our next one. All right, we'll look those down there at the bottom. So now my organic functional group is here. I have the COOH. So I have the COOH, which is COOH, which is going to be our organic acid. So back over here, so this is the organic acid, and I'm going to name this one just like this one. So this one was called propanoic acid. So the prefix prop means 3. What is there 3 of? 3 carbons. 1, 2, 3. And then it looks like they started with propane, dropped the E, and added the ending oic acid. So I'm going to count the number of carbons and change my ending to oic acid. 2 carbons, so then that is F, right? And I'm just going to draw it like ethane, drop the E, and add oic acid. So that's ethanoic acid. Sorry for the terrible little handwriting there. All right, now let's take a look at the next one. I have a single bonded oxygen smack dab in the middle of a molecule. There's my functional group. Single bonded oxygen, so it can't be aldehyde ketone. And it can't be the alcohol because that would have an H at the end. So this is going to be an ether. And I'm going to name it just like the ether on this page. This is called methyl ethyl ether. I'm going to expand this so hopefully you can see beyond, that terrible handwriting. I'm going to see whether or not it's going to let me erase. It still doesn't want to let me erase. So when I look at this ether, it's just called methyl ethyl ether. So where is methyl and where is there an ethyl? Well, meth means 1 carbon. So where is there 1 carbon by itself? Over here. Eth means 2 carbons. Where are there 2 carbons? Over here. So I have a branch on the left and I have a branch on the right. Methyl ethyl ether. Okay, so now back to our worksheet. So I have 1 carbon branch over here from the oxygen. So that's going to be methyl. And then I have another one over here, methyl. And then I'm going to add the word ether. Or, since there's both of the same, dimethyl ether. All right, let's go back up to the top of the page. Alrighty, let's identify what looks different than a carbon-hydrogen chain. I've got the carbon-oxygen double bond, and I have another oxygen, and it's in the middle of the molecule. Okay, so the one that it closely matches on table R, right? If I have 2 oxygens, it can only be the organic acid or the ester. And so what does it look more like? It looks more like the ester, right? With that carbon-oxygen double bond in the middle, right? Here's my ester functional group right here. So then I'm going to name the one that I have just like this one. But I need to examine how did they name this one. I've got the word methyl. Well, I know that meth means 1 carbon and YL means branch. Where is there a 1 carbon branch? Right here. Okay, so I'm going to name what comes after the oxygen, what comes right to the right of the oxygen, count those number of carbons, give it a YL. And now propanoate kind of looks like propane, but they changed the ending to OATE. Well, prop means 3 carbons. So where are those 3 carbon chain? Where is that 3 carbon chain? So that's 1, 2, 3 carbon chain. So it looks like I count the chain, change the ending to OATE. What it comes after the chain, give it a YL like a branch. So now let's take a look at ours. So I have the carbon chain, which is here. So I have a 2 carbon chain. So that is like ethane. Drop the E, add the ending from the reference table of OATE. So this is ethanoate, but you have to name the branch, right? So then you need to name this part next. There's 1 carbon in that branch. So then that's methyl ethanoate. Methyl and then ethanoate. Okay? Now let's go on to number 7. I have an OH, and it's an OH, and it's kind of like sticking off at the top like a little branch. So where would I have an OH sticking off like a little branch somewhere? It's not a halocarbon. Well, here I have an OH, and it's just going to be carbon chain with OH. It could be the alcohol. And the only other place where I would have an OH, this is not an OH, right? That's not an OH. The only other place where I have an OH is the organic acid, but that has another extra oxygen. So it can't be an organic acid. It has to be an alcohol. So now we're going to name our alcohol just like they named theirs. We're going to do some mimicking. Theirs is called 1-propanol because there's 1, 2, 3 carbons. That's the prop part. That's the propane part. Ending gets changed to OL, and the number 1 tells me where that OH is located. So now I'm going to count the carbons. 1, 2, 3, 4. Prefix for 4 is bute. So I'm going to call this like butane, drop the E, so butanol. And now I have to say where is the OH because with those 4 carbons, there's more than 1 possibility. So I want to give the smallest number, just like when I named, hydrocarbon branches. So this is carbon 1, 2, or carbon 1, 2, 3. I want carbon number 2. So 2-butanol. That means on carbon number 2, there's a 4 carbon chain with the OH at the end. Okay, we're just getting there. A couple more. All right. So here we have our functional group. I've got the COOH, and I know that I'm going to count the carbons, and I'm going to change the ending to oic acid because that's what's written on table R, right? Count the carbons, ending becomes oic acid. So 3 is prop. So it's like propane, but it's not propane. Drop the E, add oic acid. No numbers are involved because that has to be at the end. So now I have a carbon-oxygen double bond with an H. So it's either going to, with only 1 oxygen, it's not going to be propanoic acid. It can't be a ketone because it's at the end. A ketone has to have the carbon-oxygen double bond in the middle. Right here is my functional group. So then when I name this, I'm going to name it just like they named theirs on table R. We've already done one of these. This is an aldehyde. So 2 carbons is F. So it's like ethane, drop the E, add the ending AL. Be very careful in your writing because we have OL and AL, and A's and O's look very similar. You wouldn't want to lose points for messy handwriting. Okay, so last one. Oh, well, actually, we're going to do the structures of organic compounds in the same video. So we'll do the next page together as well. So here I have that carbon-oxygen double bond in the middle. This is a ketone, right? If you don't believe me, check table R. It's going to be the one that looks just like, almost like a ketone. according to table R, we count the number of carbons. So that's 4, right? 1, 2, 3, 4 carbons. 4 is bute. Okay. So we do like butane, drop the E, and we're making the ending -one, right? So butanone. And now, since there's more than one spot that could be, because it could be here, and this is also here, so then this is going to be 2-butanone. All right, so now let's go on to your next page. Now we're going to do structures. Okay, so I'm going to mimic what's going on table R. So first I have to figure out which one I'm looking at. I have the ending of oic acid, right? I have oic acid. So that means I have an organic acid. And I have the prefix bute. So that means I have a 4-carbon chain. So I'm going to always start with the carbon chain. So 1, 2, 3, 4. And now I just have to do this whole functional group, the oic acid part. So I'm going to mimic, what does the functional group with the acid look like? Okay, it's over here. So I have the carbon COH and the carbon oxygen double bond up here at the top. So then I'm not adding an extra carbon because then it would be more carbons, right? I got to keep the carbons that I have. So that's where that oxygen double bond goes. And then there's the OH. But it looks a little weird. Don't forget, every carbon, every organic compound, carbon has to have 4 bonds. So then this one has to have 4 bonds. This one still needs 2. This one has 2. It needs 2 more. This carbon has 1, 2, 3, 4, and we're all set. Let's go on to the next one. So looking very carefully at my endings, I have the ending Al. So this tells me that I need to find that's an aldehyde. And then meth means 1 carbon. So I have 1 carbon, and I need to make it look like the aldehyde. So I have aldehyde, which is the carbon-oxygen double bond with the H at the end. So I have the carbon-oxygen double bond and an H at the end, making sure that every carbon has 4 bonds around it, right? Every carbon gets 4 bonds. How many bonds does this carbon have? It has 1, 2, 3. It needs 1 more bond, and then an H. Yeah, this was a tricky question on a Regents exam last year. A lot of kids had this part right, but then forgot that extra H, forgetting to make sure that carbon had 4 bonds. That's why I'm emphasizing it. Okay, so then the next one, we have methanol, OL. OL means that we have an alcohol. So alcohol. And I have meth means 1 carbon. The alcohol means I have a OH. So now I'm just going to draw the OH. But that's not methanol. I got to make sure that every carbon has 4 bonds around it, right? And then what's on the end of those 4 bonds? Hydrogens. So now the next one, I have ONE, which is the clue that's telling me that this is a ketone. So then I have to match the ketone reference table. But I have bute, so I have 4. So 1, 2, 3, 4. And now I have to put the functional group in. So with my ketone, right, the carbon-oxygen functional group is right there in the center, right here in the center. And so I'm going to put that in there. So I'm going to put that here. It's the same as if I put that there, because if I did this mental flip over, that's the same position. Make sure carbon has 4 bonds around it, right? And then hydrogens at the end of each. So this carbon in the center already has 4. This one still needs 2 more. And then this one needs 3 at the end. Okay. Now I have my next one. I've got diethyl ether. Well, they're telling me ether. That one's pretty easy. So ether functional group, right? Diethyl means I have two carbon branches off of that ether. So the ether is this, and I have two carbon branches. So I have a 2 carbon branch and a 2 carbon branch. Do not forget, carbon gets 4 bonds around it. So 4 bonds around it. For the sake of time, I'm not going to do all of those H's, but you know that there's H's there. All right, let's go up to the top. Now I have this really weird looking thing here. This is methylmethanoate. Ugh, I don't even like the sound of it. So it ends in OATE. So I'm going to find the one that has the same ending. And now I'm going to mimic that. So that one that we had was what? That was methylmethanoate. This is methylpropanoate. So basically, I have, again, so what we just talked about earlier, let's change color to this light green. So this methyl part is right here, okay? Because that's the only thing that's got like the 1 carbon that can indicate a 1 carbon something. And then the propanoate, remember prop means 3. Here's those 3 carbons. Okay, so then I need to go and I need to mimic what I see here. So this is methylmethanoate. So I have a 1 carbon branch. So I have methanoate. So that means I have a 1 carbon chain. And I have a 1 carbon branch off of that. So here's the functional group. So the 1 carbon branch is what comes after that oxygen. And then I have this 1 carbon branch. So the last thing, so then my 1 carbon chain. So then everything making sure we have 4 bonds around every carbon. This carbon only has 3. What does it still need? 1 more, right? This one's a tricky one, right? So number 6 and number 2 are tricky. Those little 1 carbon ones. Okay, so here I have the ending OL. OL means I have an alcohol, right? Which is an OH functional group. And it's on carbon number 3. And there's a 5 carbon chain. So 1, 2, 3, 4, 5. And now on carbon number 3 is my OH. Last but not least, every carbon gets 4 bonds. Okay, 4 bonds around every single carbon. Hydrogen only makes 1 bond, oxygen makes 2 bonds. Okay, so now I have methanoic acid. So methane means that I have a 1 carbon chain. And I have oic acid means it's an organic acid. So I am going to draw the organic acid part just like we see here, right? The carbon-oxygen double bond with the OH. The carbon-oxygen double bond with the OH. Last step, make sure every carbon has 4 bonds around it. That carbon has 3 bonds right now. It needs that 4th bond right there. All right, again, anything with those 1 carbons is tricky. All right, our next and last 2, I have prop and I have Al. So then the Al means that I have an aldehyde. Prop means 3 carbons. So I have 1, 2, 3. And I'm going to make it look just like the one on table R, the aldehyde, right? So look how messy my table R is. So I'm going to make it look just like this, right? I'm going to put that carbon, oxygen, and the H at the end. So I'm going to put that carbon, oxygen, and H at the end. And of course, that last step, making sure those lovely carbons have 4 bonds around each. Okay? And then hydrogens. And our last one. All right, so I have 2 pentanone. The one means I have a ketone. And so pent means I have a 5 carbon chain. And this 2 means that's the location of that ketone functional group. So 5 carbon chain, 1, 2, 3, 4, 5. On carbon number 2 is that functional group of the ketone, right? Go back and let's look at the ketone. Where's the ketone? right? Here's our ketone, right? Carbon-oxygen double bond in the middle. And the last step, of course, of all times, making sure every carbon has 4 bonds around it. And of course, you would be putting in all of the H's, right? Making sure that you put in all the H's when you have a test because you wouldn't want to lose credit. But for the sake of time, I left those out. All right, so hopefully you have a better understanding of what to do when you have to draw or name or identify organic functional groups. Until next time.